Mid-air refueling, also known as aerial refueling, is one of the most impressive, precise, and nerve-wracking operations in modern aviation. And the United States Air Force performs it every single day, often in the dark, at high speeds, and thousands of feet above the ground. In the next few minutes, we're breaking down exactly how the Air Force keeps its fighters, bombers, and transport aircraft flying longer, farther, and faster than almost any other air fleet in the world. The secret to this capability lies in aircraft like the KC-135 Stratotanker, the KC-10 Extender, and the newest tanker, the KC-46 Pegasus. These giants aren't built for combat. They're built to keep everyone else in the fight. Their entire mission is simple: deliver fuel in midair. So why refuel in midair at all? The answer is reach. Without refueling, even advanced fighter jets like the F-22 or F-35 can only stay airborne for a few hours. Bombers like the B-2 would struggle to cross oceans, and transport planes, moving troops or humanitarian supplies, would need to land constantly. Mid-air refueling turns short-range aircraft into global assets. It lets jets reach distant targets without stopping. It allows rapid response to crises anywhere on Earth. And in wartime, it means fighters can stay on mission longer and strike targets that would otherwise be out of range. But it comes with a catch. You have to bring two massive pieces of metal within just a few feet of each other while both are traveling at hundreds of miles per hour. Inside a tanker like the KC-135 or KC-46, things are surprisingly calm. These aircraft carry tens of thousands of pounds of jet fuel in their wings and fuselage, but the heart of the operation is at the very back, where the boom operator works. This specialist performs the refueling itself, operating the system that connects tanker to receiver. Their job is part pilot, part engineer, and part surgeon, because the margin for error is incredibly small. There are two main methods of aerial refueling. The first is the flying boom system, used by most U.S. Air Force aircraft. This system uses a long, rigid, steerable tube controlled by the boom operator. During refueling, the tanker flies steady and level. The receiving aircraft, like an F-15, an A-10, or a B-52, approaches from behind and slightly below. The boom operator then guides the boom into a receptacle on the receiving jet. Once connected, fuel is pumped at extremely high pressure, sometimes over 1,000 gallons per minute. Refueling isn't always this smooth. Weather is one of the biggest challenges. Turbulence can make stable flight nearly impossible. The second method is the probe and drogue system used by the Navy and many NATO aircraft. Instead of a rigid boom, this method uses a flexible hose with a basket on the end. The pilot of the receiving aircraft flies a probe into the basket to make the connection. It's more forgiving in certain situations, but transfers fuel more slowly. Here's what the refueling process actually looks like from start to finish. First, the receiving aircraft approaches the tanker from behind, matching speed and altitude almost perfectly. The pilots hold a formation so tight that they're sometimes just a few meters away from the tanker's tail. Next is the connection. In boom refueling, the operator gently flies the boom into the receiver. For probe and drogue refueling, the pilot flies the probe into the basket. Once locked, fuel begins flowing. Depending on the mission, this can last anywhere from a few seconds to several minutes. Throughout the entire transfer, both aircraft must remain rock steady. Turbulence, crosswinds, or even slight pilot inputs can cause a disconnect. Finally, after fueling is complete, the boom retracts or the pilot backs out of the drogue. The receiving aircraft dips slightly, slides away from the tanker, and returns to its mission. Thunderstorms and high winds can force crews to refuel at alternate altitudes or delay missions entirely. Refueling during combat adds another layer of risk. Bakers are large, slow, and extremely valuable, so they stay far from enemy air defenses. Fighters often sprint into combat, burn a massive amount of fuel, and race back to tankers waiting hundreds of miles away in safe airspace. Even when conditions are good, the operation is mentally exhausting. Pilots train for years to develop the fine motor control needed to hold formation so close to another aircraft. Boom operators train just as long to master the precise movements required to guide the boom safely. Mid-air refueling doesn't just support missions, it enables them. Whether it's bombing runs, humanitarian airlifts, fighter patrols, or global transport flights, nothing projects military reach like a fleet supported by airborne tankers. And the future is already arriving. The KC-46 includes more automation and advanced sensors to make refueling safer. Experimental drone tankers are being tested, which could eventually allow autonomous refueling with no humans on board. From the outside, aerial refueling looks like a simple connection between two planes. But behind it lies decades of engineering, intense training, and a level of teamwork unlike anything else in aviation. It's one of the most dangerous, delicate, and essential missions performed in the sky, a quiet backbone of American air power, keeping jets aloft around the clock and around the world. But if aerial refueling is challenging during the day, doing it at night takes the difficulty to another level entirely. At night, pilots lose one of their biggest advantages, depth perception. Instead of clearly seeing another aircraft just a few feet away, they're looking at a mostly black sky with only a handful of dim reference lights on the tanker's belly and tail. The receiving aircraft often has to approach using nothing but formation lights, infrared cues, and blind trust in the pilot in front of them. Most refueling at night is done under limited lighting to avoid detection, especially during combat operations. Tankers switch their visible lights to low-intensity modes, and in many cases both aircraft turn off external lighting altogether and rely on night vision goggles, or NVGs. Under NVGs, the world turns into a grainy green tunnel, and the tanker becomes a faint outline with tiny glowing points marking the boom, the wingtips, and the refueling receptacle. Pilots describe it as trying to park a car inside a moving garage in the dark while wearing sunglasses. The boom operator's job becomes even more demanding. Instead of visually tracking the boom in natural light, operators rely on infrared cameras, refueling pods with NVG-friendly lighting, and their own instincts built from thousands of hours of training. They make tiny adjustments, sometimes movements smaller than half an inch, to safely connect with the receiving aircraft. Weather at night is also a big factor. Clouds and turbulence that might be manageable in daylight become far more dangerous when visibility is limited. Tankers often have to climb above cloud layers or pick alternate refueling tracks to find smoother air. Communication becomes critical. Pilots talk constantly over secure radios, calling out drift, adjusting formation, or warning about turbulence before it hits. Every instruction must be clear, calm, and immediate, because there's no margin for confusion when two aircraft are flying that close together. Despite all of this, night refueling happens every night, all over the world. Stealth bombers refuel under total radio silence. Fighters top off before sunrise strikes. Airlift crews take on fuel while moving relief supplies across continents. And tanker crews fly hour after hour through the darkness so the jets they support can stay airborne and mission ready. Night refueling is a reminder that aerial refueling isn't just a technical feat. It's a mastery of trust, precision, and skill carried out by some of the most capable aviators and operators in the world.